Folks, we're back. I think I'm gonna just reset a little bit and do some experimental engineering stuff with Puffer. I've been running support for a few different projects in the background, and if I have to deal with one more piece of absolutely deranged research code, I think I'm gonna snap. So we're just gonna do some cool engineering right now. That's what we're gonna do. It's like, the only thing I'll say is it is astounding to me how willingly even very good scientists will just throw away 99.9% of their compute. Yeah, we'll just, buy all this expensive hardware, run it at 0.1% of what it should be running at, and then wonder why none of our stuff works. Drives me bonkers. But enough of that. We're gonna do some cool stuff. I do want to just briefly check on the experiment that I ran from before. Just briefly check on this. Okay, so this is interesting, right? Because we have this one, and this one. So we'll see whether these intersect or not. This is with the optimized hypers. Let's go like this. We'll see, whether this stays above the other curve. It's interesting that it has this fast growth at the start. We'll see if it maintains it. And yeah, this is very, very clean though. So we're expecting about a 4.5 out of this, I believe. Cool. Make sure I don't have any reasonable messages from reasonable people on Discord. I do not. Okay. So this is what I had planned for right now. I've been thinking about doing something like this for a while. There's a lot of Python code in PufferLib, and it's pretty much all identical as well. Every environment needs a Python binding, as well as a Python binding, and the code is it's kind of gross. So what I want to do today is I just want to look at some different binding options and see if I can think of anything that would replace that binding. Just do that for a little bit, What's the built-in one with Python? Is it C-type? It's just what are the common C options for Python? I believe C-types is the built-in one. Yeah, C-types is the built-in one. No compilation. Commit to calling precompiled C libraries. Less efficient. Why is it less efficient? High performance. And Python C API. Why is C types perf? every call involves interpreting the signature. Compiled bindings. Is there a built-in iPref option? Python C API. Direct access to Python objects. Compiled into shared libraries. No runtime overhead. Direct memory access. Okay. Compare to Pi, line 11 for pure C extensions. Highest possible performance. Nearly identical once compiled. We don't like C++. But these Pi objects are totally gross. Give me an example what it would look like if I am NumPy arrays only. Should be able to just buffer. You can leverage the NumPy C API. So you get two Pi objects. I don't like this total mess here. Parse the input arguments. Yeah, this is a mess. There's a lot of Pi object mess here. In Python, just has memory use get start. So it's here. C star or similar. Is there a way to less API stuff? Add arrays. Okay, so this is, yeah, this is fine. Validation. 1D double contiguous same length. Yeah, that's just a massive amount of stupid code. Let me see if I can figure out why the API is like that, and if Grok is just stupid. So you get this PyObject API. I see, you can only pass like this, really? This is the only way to use Python API with PyObject. Our signature. Can't I write functions specific sig so I can avoid unpacking and packing. Python C API design enforces this. Okay, so you can pass a one thing to the signature, I guess. This is them making wrapper garbage. Okay, so the fast call thing here. This is star. So this API is kind of gross because you don't get signatures directly. So Python must be doing something like this under the hood, right? So what is this? Extension module. It's a very odd API. This is like trying to write Python in C. PyBind lets you define the signatures. See, this is just awful. This is awful. Required for Python object integration. Method table for the type. You know, this code is absolutely terrible. I don't understand. Is this that Grok is stupid, or is this that the Python API is stupid? None of this should be required. Welcome, YouTube folks. I'm currently seeing if I can find an alternative to Python. The goal would be to make a general purpose wrapper that essentially just takes your C environment and then runs a bunch of copies of it for you. And I'm currently trying to figure out why the Python API is this bad. Or if it's just Grok being really dumb. Like, I didn't ask for this, right? Py-type object, what is this? This code is terrible. Why is there junk in the C struct? Pure C. Array increment type. It's funny because this is like absolutely trivial in pure C. And somehow with the Python API, now it's hard. How does that make any sense, right? Incorrect. Okay. Well, this code is freaking horrible. Is that Tetsuo? Yeah. Do you have a good solution for this? C is like so nice and easy, and then as soon as you try to do anything Python related, it's awful. I currently have like this massive amount of Python code where every single environment in PufferLib needs like 100 lines of Python that just like redoes the entire header for some reason, because Python, and then it redefines all the methods as they are in C, and then you need to do the same thing again in Python. I've like looked at this, I've looked at PyBind, but I don't want to open the door to C++ nonsense. I think C types is probably too slow. It's such a mess. Like, what is this? What in the heck? Either not showing the message or it's emotes, which take forever to load. Ah. Also, X needs to fix their streaming stuff. It's kind of a mess as well. It's like X doesn't show you view count and lags and stuff. Twitch has a ton of bots, so you have to ban like 3 or 4 bots a day. And then YouTube has too high latency. I don't know. The thing that's tough here is I can't tell if this is just Grok being incredibly stupid, or if this is the Python API being stupid. Can't stream on my monitor. Okay. This is almost reasonable. I don't know why this isn't an int. Array increment. Okay, this is a C type. Init incrementer. This takes a pi object array. Does a bunch of error checking. That's like way better at least. Free any existing incrementer. Oh, now it's storing it as a global. Shoot. I don't like that either. Do people actually use this thing directly? Is there like a PyBind but pure C? Okay, this is like less insane. I mean, I can just use it and with C. Is this good though? And is it fast? Okay. This is C. Plus class. Yeah, but then it does all this nonsense. I swear, it's like the second you move away from just like pure C, stuff just goes insane. Okay, this is fine, right? Pi bind array of double. Why the hell is this an array of double? Like, no, stop. Go back to the Python API. Can't even do all the checking on init. Okay. This is now C. Okay, so here's the cast. Clean up. Returns the pointer as a Python int. Is this the best way to do it? It's not terrible. A little tricky to figure out how you do this. I'm trying to think how you would do this then to like bind whatever env. The ideal signature here is that you bind, I think. It's friggin' bots. I'm trying to think if what I want to do is even possible. I want to make it so you don't have to write a per env like binding. You just need to specify essentially what the functions are. So here's the environment. So yeah, this would be like what our functions would look like. Okay, so something like this works if you can handle the types of different M's. Okay, so example, you have a couple of these headers. And then, yeah, so this is what you would expect. This is fine. This is all just error checking. So you make this wrapper thing. And then they had to hash include both of them. Pound include. This will then build one big extension. It's the annoying thing. And we have to deal with namespace issues, right? Let me think about that. This actually lets you do function pointer to allocate. Void star. This could be void star as well. Is there a way to do this like how I'm thinking, or is this dumb? Because you do end up needing this like big table right now. Okay. Idea. I have an idea here. Let's say that we are willing to have a very small piece of per env code, and we don't want it all in one file. Okay, so something like this is totally fine, right? You have a relatively short piece of code that says how to bind env. And then this is like, let's say that you have a specific env A, right? H, A dot C. That's interesting. Why do you need this pi init env A? Yeah, okay, so this is getting closer to what I wanted. This actually feels like this has potential. Every extension must define an initialization function. Oh, fair enough. B. Okay, so I don't want to redefine nb dot h. Ah, hang on. I think this might have messed it up a little bit. So this is this environment table. Function pointers to be defined in env.c. Oof. That's really bad, though. Yeah, that's real bad. But the thing is, the macro isn't even better because the macro is just hiding this. Specific files. Okay, so this is just an environment, right? A.c. This is really like env binding.c or whatever. So this is clean now, right? This doesn't need to do anything. Yeah, that's gonna screw some stuff up, right? Yeah, I don't like this piece here. So this is gonna be super gross. If they all have the same signature, I think I have the problem solved. Is there a way I can do that? Not really. Okay, so here's our nth binding. You know, this is a file, but we only need this once. And then allocate has extra args. Env a.h. Okay. Extra args. Oh, you know what? If I do this, And I can just set the extra R because I don't need to modify this signature. Hmm. Doesn't need length either. And this no longer needs, I guess this still does need an init function. Because yeah, you sometimes set hmm. Init. Oops, it gets stuck. Yeah, we don't need all this stuff in here, this wrapper. This is now like working with an exceptionally stupid junior engineer, so it's getting better. But for anything I have remotely any experience doing at all, like I haven't used the Python API, it doesn't do much because it writes such bad code. Okay, so this thing's still a mess. Okay, cool. Now we have our validation in here. Okay, then we can clean this up further, but at least this is better. I mean, this is like actually not even like dealing with a stupid junior engineer. This is dealing like with an exceptionally stupid junior engineer. The only reason I'm doing this is because I haven't used the freaking Python API before, and I imagine that compiling stuff's gonna be a pain. Um, you are not authorized to use this service. Okay. Well, I might be able to take it from here anyways. Oh, is X down? Yeah, X doesn't freaking load. That's crazy. Is my stream on X down as well, or is it just the, doesn't look like it's down. I mean, this is pretty close, though. Okay. So this is env-binding.h. Let's start on this. Thanks, Tetsuo. I assume that the UI like broke or something because I no longer see the stream number live. All right. I mean, this is basically there, right? The only thing is that this kind of calls init a little bit early, right? Yeah, so this kind of calls init a little bit early. Just get rid of this first. We don't need these length params. Oops. Hang on. Oh, because it's a pi array object. That's kind of gross. Okay, so we'll keep it like this for now, I guess. That's better. Do I have any no argument m's I can use to test with? Well, you still have to set the size, was it size, row, and column or whatever? Just size. So maybe we'll do squared as our first one. With this. Now you have to define, it's a little tricky because the init method, right, already calls init. Well, I guess it's because this observations array is already set up. It just needs size afterwards. So maybe I can do it here. Let me just put size. Size is 11. Okay. Okay. I just want to see how this was bound initially. It's probably way up here. Yeah, it's probably like way up here. Does this transfer to human brain organoids, a reinforcement learning using these libs? Oh, I thought my screen was screwed up. That's a funny name. I I don't even know how you would define that, right? You can't run code on brains, right? Organic neural networks. Is that even a thing? Is this like trying to make cells that behave as neural nets, or is this... So this is trying to make physical cells. Can you run code on them? Flat sheet electrodes. Huh. I didn't even know that was a thing. Well, the issue is going to be that you can't really run code on them, right? I can't, like, download PyTorch and or GCC. I mean, if you want to see the type of stuff I develop, right? We do like ultra high performance test environments for reinforcement learning. Everything from like really simple classic stuff, just way faster, up to like, you know, new types of interesting tasks. This is like a miniature version of Dota. We've got this like miniature MMO, and they're all very, very fast. So like general purpose reinforcement learning techniques, but I don't know how you run code on cells, right? They can form. The basis. The neural... So that seems like you're using a language model to train cell outputs, not the other way around, right? I mean, yeah, if technically, right, like if you have something that responds to stimuli, you should be able to optimize it. But I don't know how any of that works in practice when you're dealing with like, you know, physical cells that can't run code. Mm-hmm. Okay, we get some errors. I'm really surprised you can actually do that with a username on X. I guess they allow Unicode. You can put emotes in your name, so I guess it makes sense. It's still funny though. That's like crazy that's even in the spec. Like if you're clever, can't you even like you can make your username cover the whole chat panel as well, right? I've seen people do that. That's crazy. I'm surprised they haven't filtered modifiers by now. All right. The thing I'm trying to do at the moment is I'm trying to get a way better way of binding all of these different CNs to PufferLib so that you don't have to go through Python and write a whole bunch of intermediate jank. The idea is going to be that before this you had to write like 100 lines of code to get your M to work with PufferLib, and after this you should have to write like 5. At username has blocked you. That's funny. Implicit definition of step. Close env. I'm gonna look into this. We may be able to use it. Yeah, I mean, I've never even like remotely thought of that domain. We do have really nice hyperf simple RL tools. I have no idea how code in general interacts with that stuff. I don't know, like with what frequency can cells even respond to stuff? Because we basically can give you data at millions of steps per second. Like traditional silicon chips excel at high-speed calculations. So particularly adept at handling complex tasks. Voice recognition. Wait, you don't have cells in a petri dish learning voice recognition, do you? Is that actually a thing? Activation functions swap or not, they're just suggest they're not. Jason, we've been using Gelu lately in some of our nets. I don't know if it makes a huge difference. Yes. Well, I mean, if that actually works, and like, there's a high bar for it working, like, but if that actually just works, that it can just like learn that, then we probably shouldn't be here just doing pure like scaling transformers with like 99% of the money. There probably should be some more investigation into that. In fact, there probably should be anyways. Do we actually understand like the mechanism by which these things like learn and update themselves? Or is it still like pretty well like pretty not understood? Because my impression was like, yeah, there's some brain inspired neural net design stuff, but we actually don't really know how the hell it works. So, like, we can't really build neural nets that do that because we don't understand how it works. Is that not the case? I mean, it doesn't really matter for any of the stuff I'm doing, right? All like the stuff I'm doing is mostly like just how do we learn, how do we get this stuff working on just absolutely ludicrous amounts of data very, very fast. Like here, I posted this the other day. So this is just the dashboard from a completed run. This is 107 billion steps of training data in about 50 hours on one GPU. For context, that is like more data than is used to train all of GPT-4, for instance. And this is like playing 2,000 years worth of games. So, you know, all the stuff I'm doing is kind of general purpose in that sense. Like, we could decide that all our models and algorithms are stupid tomorrow, and my stuff would still be useful for whatever we replace it with. They're non-deterministic systems, right? I thought you may be running quantum. There's no quantum anything here. This is, I mean, the goal of what this is, right, is like reinforcement learning is really slow because people wrote really slow code. We make it run 1,000 times faster, and then we do a whole bunch of comprehensive research on what works and what doesn't, which we can now actually do because we can run experiments fast enough to actually get those results. That's mostly what I do with Puffer in a nutshell. And you know, we've got all the demos on the website. C reset, C step. Act like quantum systems. How is that possible? That doesn't seem physically possible, right? Like neurons are not quantum entangled particles. It says intuition, co-processing. Yeah, but intuition is... So there's a difference between non-determinism and what quantum does, right? Non-determinism just means random. Non-deterministic in the context of algorithms means that you're kind of effectively evaluating all possible choices at the same time. Right? There's a huge difference between those things. Like intuition is just pattern recognition, right? Pattern recognition is learnable. That doesn't even require non-determinism. We don't know, and yet they act like quantum particles in some ways. I would be really hard pressed to believe that, like, there's some fundamental theory of conscious and actually all the neurons are quantum entangled or something like that. I'd be like really hard pressed to believe that. I mean, that would be an awesome day for humanity, but I doubt it. So I don't know how they behave like that. I would imagine it's just very good pattern recognition without conscious awareness. I don't know what that acronym is. Right? Yeah, that would be like so, so cool, but I doubt it. I would imagine it's just like some vastly better learning algorithm than what we have now that we haven't been able to explore because like GPUs don't efficiently implement learning the same way that the brain does. It's probably something like that. Sorry, steps, it's like a black box. Without conscious. It's not stateless though, it's stateful. You don't, so like you get inputs, you learn from that. That doesn't seem different. We don't know how they're making association steps within the process. Yet they do. It's accurate and fast. Well, anything's faster than an LLM, so that's like, sure. Don't know how they're making steps within the process. Why? It's because it's stateful, right? You don't know how it's stateful, but like when you give it an input, the thing doesn't remain unchanged. It learns actively. I don't. Nobody's ever really explained to me how quantum has any relevance to anything, except like, yeah, there's some crazy thing where you can like. I don't think it's actually doing like. It's not actually being like a non-deterministic Turing machine, but it kind of acts like it does in some ways. I don't really know the details of quantum. I haven't really seen anything from there. And it's also not required for like huge amounts of technical advancement. It's not gated behind quantum necessarily. Like there might be a whole bunch of stuff we can solve that we don't know is even possible right now if that actually works. But like I don't know. In my view, right, I have pretty well in my sights a massive increase to our capabilities in general purpose learning just with what I'm doing here. Yeah, but you can't measure reasoning, right? Like it's a fuzzy term. That's the problem. Frustrating. Pretty sure gonna tap in again once we have. Yeah, sure. Feel free. I stream pretty much all my dev. This is kind of like just watch reinforcement learning progress being made live. Sometimes it's cool algorithm stuff, sometimes it's low level infra dev, but progress is made nonetheless. That actually builds. Huh. Progress is made nonetheless. I mean, this week has been ridiculously good for RL with some of the things we've come up with. Or oh, okay. It's just we'll fix the paths later. Oops. Cannot import end drawing. Ah, I see. So you do need to link RayLib still, which is a little annoying. Okay. That's not bad. Segfault. But wait, now I can actually compile with address sanitizer, can't I? Because this is just running C now. Where's my F sanitize? Ooh, that's actually really solid. Look at that. Debugging now works through the env. Answering some messages on the side. We do a little bit of support while we do a little bit of dev. Well, this got set correctly, so why didn't that get set correctly? Ah, that'll do it. That'll do it. Let me see if I can finish these thoughts here. Call reset. No attribute end reset. Cool. So I didn't do reset at all. That will do it. This actually should go up top. So this actually works. That's crazy. So this is no Cython C environment. No Cython C environment. That is awesome. And it's only 150 lines of like general purpose bind code. Okay, I'm gonna figure out from here how I make this work more broadly. I'm gonna take a couple quick minutes though. There's a restroom, I'm gonna grab a drink, and then I'm gonna think about how we handle more variable args, and then I maybe get a perf test going. I'll be right back. Okay, we're back. This is going to be cool. But I have to figure out how to handle variable arcs. You clearly need to be able to define a function, right? You are going to need a little bit of PyBind for this. I don't think there's any way around it. Or not PyBind, a PyObject. So the issue here is this line, this nvinit. This doesn't change at the very least. Right, this doesn't change. So if I call this base init, and let's say that you have to define nvinit, so you call base init like this. Okay, let's do this first. Undeclared here, not a function. Okay. This works. This still works. Okay. That's cool. Pylong from void pointer. No pylong. Oh, this returns an int. Wait, pylong from Oh, it's a pi object. Ugh. Cool. So this is not terrible. And this gives you the env. Segfault. Lovely. Still segfaults. Base init should give you an M star. Ah, wait, init env requires at least 5 arguments. That seems suspicious, but we'll go with that for now. I mean, this will work for everything. You can literally even do, was it default init? So you can even do this, and now you have a default init. I think most environments are going to need args though. I mean, you could 100% do this with macros, but it's going to be stupid. I mean, I can see this working. You know, because like in this case, you can delete this init, right? Because Square doesn't have one, right? Got some time code review? Yeah, I can do that. You want to see what I've been doing? It's pretty cool. Does this build? Yeah, it does. So this is, so far, what a binding would look like if the thing I'm doing works. This is what you would have to write for a binding instead of all the Python. Yeah, this would replace Python, and it fixes debugging through Python. You can get full stack traces all the way down to C. And it compiles instantly. Let me jump on Discord. Hey,
Yo,
how's it going?
chilling. Just charging my car right now. Let me go ahead and drop a link.
Yeah. It's 150 lines at the moment. I still have to do like the loop over M's and stuff code, but let's say
Right.
that this thing gets to 200 or 300 lines, and then it replaces like 2,500 lines worth of stupid binding code right now.
And if you need to do like any kind of, I guess, weirdness on the binding, would we just do that on the Python side now?
No, you can still do it,
For
and this is still C.
oh,
Yeah, it's just C. So if you have any
okay,
weirdness, you can do it in the Python side or the C side.
okay. So
No,
like yeah, for
no
like memory
intermediary.
allocation stuff. Yeah.
Yeah.
Okay. Cool.
So I'm gonna see how this goes, but I don't know. This seems like this could definitely be something good.
Is it like some Python library?
No, it's the built-in Python C API.
Oh,
Yeah.
lol.
Well, it's the thing is, it took me forever how to do this because it's like the way they expect you to do stuff is really stupid. It took me
Mhm.
like half an hour or 40 minutes, whatever, with Grok for it to just like give me some code that wasn't completely disgusting, and then I had to change stuff. So I don't know what it is, but like nobody uses this thing because all the code sucks.
Sure. I could see that.
Anyways, where are we starting?
All right, so let's just probably start with just the .h file, and really kind of what I wanted to do is like kind of do a review with you before we go into multi-map stuff.
Yes, okay. So
And
yeah,
just kind
things
of
are
like
gonna
go
get
ahead and just
harder.
like kind of walk you through how I set up the grid and collisions and stuff to be
Hmm.
at a decent speed. Right now we're at like 730,000 to 830,000
Hmm.
um train speed. It just depends on how many active agents there are.
And
And
and if you do have the graph or the dashboard, like is it all time spent in the environment or what?
yeah, I'd say right now environment speed is it ranges based on how many what's it called? Um how many parallel M's are running for some reason. I think there's like some overhead based on if you have like an optimal number.
Wait, I see this train here.
Yeah.
So this is the default in dev at the moment is 2 workers, 2 M's, batch size 1.
And then if you go to the M side of num M, so that 128
How many
works
cars?
pretty well because on the map that I was training at, we had 8 active agents, and that for some reason ended up being
Powerful.
faster than 256, even though 256 would equal it out to 4096.
Hmm. Faster in steps per second or training speed?
What'd you say?
Like faster steps per second?
Faster steps per second training speed. Sorry,
Interesting.
like faster. Yeah, yeah. That's an untrained speed. Yeah.
Hmm. Interesting. Well, we'll be able to look at that. No big deal. Um, cool. So we go back to
And yeah, and
here.
so I was actually able to get it training with your latest dev changes. Pretty much only thing I had to change was the batch size.
The batch size?
It yeah, I just changed it to be like
Oh
130,000
yeah.
in the 4:1 ratio.
Yeah, and it'll do gradient
Everything else,
accumulation over that mini batch now.
and it even has like the cosine annealing that you did.
Mm-hmm. It's good.
When I tried other maps, I know it didn't full solve other maps. It got like 80% on one of the other maps, and then I haven't tried the third one yet.
Well, it's gonna get
But the
easier when
first,
we have a bunch of maps.
but yeah, I mean, I figured it's just like an entropy thing, and it just
Mm-hmm.
happens to not. It just didn't run in that direction and didn't
Mm-hmm.
see it, and it got too many negative rewards before I could ever find it.
Yeah, I mean you'll be able to run sweeps once this thing. Yeah, you'll be able to run sweeps. I'm pretty damn confident that the RL at this point. Um, the new changes were very, very good.
Yeah, so far I'm pretty happy with speed. I mean, if it could be up to 1 million, that'd be
Oh,
great.
it
I
will
I have
be.
an idea.
It'll be.
I'm pretty confident. Like, what's the bottleneck to get to 1 million?
What's the M% time?
M% time. It's like 2 to 5%.
Oh, so you are actually bottlenecking on policy.
Yeah, a lot of it is on.
It's probably the road points encoder.
It's just like there's just a lot of points.
Yeah. Okay. Well, we'll look at that. We'll figure something out for that.
But it's weird because it does drastically change on the nth percentage time based on how many M's you have going on.
That's normal, though it should get better with more M's, so something's screwy there.
Like if I have like kind of a smaller M on this one that has 5 active agents, it says M's times at like 1%. But if I were to like shoot it up to more M's, then it would increase for some reason, which I think is just the
It's
overhead.
possible that
But
the net is just bigger. Like the optimal batch size is going to depend on the network architecture as well.
sure.
So don't worry about that. Okay, so we've got.
Which I just did like a super simple network architecture. I basically just did like
Well, yeah,
a
but
linear layer.
I haven't timed like pooled entity encoders before.
Ah.
So maybe we'll have to fiddle with that. That's no big deal, though. I can help. Yeah, I just want to make sure that we actually get like, the sooner we get stuff where it's like, hey guys, you should consider this sim because it's way faster than
Sure.
yours, and it's actually like a quarter of the code or whatever.
Yeah, I think I only really took liberty in 2 places away from their standard implementation. One, or I guess 3. One was what we talked about, but doing the grid style collision instead of the bounding volume hierarchy. The other was the stepping of the dynamics. I wasn't certain how their actions range was negative pi to pi. It just mathematically didn't make sense to me.
Wait,
So I made it negative
pi.
1 to 1.
Negative pi to pi should be it can turn 180 degrees in either direction. Right?
If you see how the equations that they use to step through the dynamics, it doesn't make sense how negative pi to pi would.
That because of the tangent
Yeah.
or whatever. Yeah, okay.
Yeah.
That's fine.
Yeah. So
that could
it
just be a
just
bug.
didn't make sense.
We can ask him, and if not, like ask him in the Slack, and if not, it's probably a bug.
Yeah. Because like the second I switched its negative 1 to 1, like the actions actually made sense. Like half the actions went one direction, the other half went the other direction at increasing degrees of the turn.
Okay, we'll see how this goes. We might want
breaking it apart into another struct.
I'm seeing right here, this is like, what would you even call this? It's not a point. A vector or something? I don't know. We'd like whatever the standard name is for position velocity information like this. Well, I guess you have goal position, but not velocity. Something. There are a lot of these.
Yeah, I mean, there's going to be a lot of those because there's trajectories, and then there's current, and then there's goal, effectively.
Yeah. Well, you might have to compress some struct because presumably you're going to be getting information from like the same point. You need the X, Y, and Z at the same time, right?
You really only need the trajectory information to get the first point.
Okay, then X, Y, and Z, like you're gonna need.
And then like, yeah.
You don't like go get the X of every point, right? Like you go at like for a point, you get the X, Y, and Z though, right? When you access it,
For a point. Yeah. What I'm doing is you set the XYZ based off of the first point of the trajectory XYZ to set up the spawn.
Yeah, but then when you're doing stuff in general, right? When you're doing stuff in general, like you're gonna go access the X, the Y, XYZ. And the Z. Yeah. You're not gonna go access all the X's and all the Y's and all the Z's, right?
No. You only access like the current X.
So in that case, then even putting it into a struct should actually improve memory contiguity as well. Right.
Well, would it change anything? Because if you have the X through the VZ, doesn't it all sit in the same space, like in contiguous memory? Based on how it's aligned in the struct?
Okay, for this one, yes, but what about here? I guess these ones don't.
No, because they're in their pointers.
Yes,
right?
You understand this, right? And also, how's there a single X, Y, and Z? Oh, because this is one car.
It's one entity. Yeah.
Okay, this is one car. Okay, that's not as bad then.
It's one entity type or one entity with however many types for the entirety of the thing.
So I mean, we just depending on the usage patterns, we'll figure out what needs to be a struct and what doesn't.
Sure.
I think definitely like this is an end where if we keep it nice and clean for them, it'll make it a lot easier because they don't know like they don't have people who are as familiar with lower level dev.
Fair enough. I will say the grid collision stuff is a little bit of a mind fuck, but it does work and it is simple if you can understand like all of the arrays that are in place.
Map. So this is the map binary.
Yeah. So if you want to start on the Python file, you could look at that before going to map binary because
I think
that's
I
what
looked at
it
this
goes
before.
from.
Did this change?
No, it hasn't changed since we looked at it.
Okay. So yeah, this is like you're dumping a whole bunch of data into a binary file and then
Yep.
you're reading.
Yep.
You're very carefully reading it, knowing that this is
Yeah,
the
if you
right
mess with
way to.
anything in here,
Yes.
it will nuke the file for sure.
Yes.
Like,
Yes. We should probably figure something out for that. Yeah, we will have to look at this because this is like, yeah,
it's delicate.
yeah. I see why you have it because it's like, yeah, this is how you would do it. But I mean,
And it's fast.
Yeah, this is kind of similar to like my loading code for PyTorch models,
Mm.
right? Because I do the same thing where I have to load layer by layer. And if you screw up
Right.
anything, you're boned, and there's nothing you can do about it, and you won't get an error.
Yeah, it's actually extremely annoying if something's wrong
Yes.
because you just kind of have to go like line by line and pray that
Yes.
the one thing you put in is the right order.
Well, we have tests for this, right? So what I do is I write a test that you'd write
The
a
asserts,
test.
right?
You should look at how I do my PyTorch test because you could do something similar here, right? So
Mm-hmm.
you essentially you write a test that you dump the file from Python, you load it in C, and then you make sure that the elements, element by element in C, it's the same as in Python once you've loaded it back
Yeah.
in, and then you're good. So this is like one of the I think you see I don't write a lot of tests. This is like the only type of thing I will write a test for because otherwise you're just screwed.
Yeah.
Okay, you do not need to save the one line or whatever for the continues. Let's see. Uh, start. So set active
Oh,
agents.
you like those inside of actual
Yeah,
brackets?
because it's like they're easy to just miss them. I know
Okay.
I've gone back and forth on it, but I think now it's just I use brackets everywhere now.
That's
Right,
fine. That's a nothing change.
yeah.
So that next thing just checks to make sure that in the trajectory that we're only taking entities that are that are spawned from the start, so you don't take an entity that spawns like in the middle of the trajectory. It's a thing I
See.
went over with them in Slack because
Yeah.
there's cases where like entities can just like appear out of nowhere.
Yeah, and as well, I don't write a lot of comments. This is the type of thing I'd write a comment, right?
Okay.
When it's like you can't understand what the hell this is for, like, because this is dependent on the data.
Yeah.
Okay, relative 2D. Uh-huh. And then,
And then they scale the size just down by a little bit.
okay. So why do we have mallocs in here? Doesn't this get called a bunch?
It gets called one time at a init.
Oh. Give agent count times. Oh, because you just did. Okay, whatever. I would have done it outside, but it's not a big deal.
This is now where you get into collision land.
Mm-hmm. No, this makes sense. This is the coordinates on the grid of a point.
Yeah.
It's count times 2 plus 1.
So I'm within each grid cell.
Mm-hmm.
I'm saving the count of how many entities are actually in there.
Okay.
And then giving it the entity and the geometry index. The geometry index is relative to the road and how it's set up, because the road objects have an inner geometry array that is just a bunch of XYZ points. So you don't want to have to iterate through all of the geometry inside of the road object if it's inside that grid cell. You want to save the actual exact line segment of where it, I guess, of the position of that road segment. So when you check grid cell 45, you know that it is road segment 5 and geometry 49,000 or something. So it's an optimization to not have to loop again by just adding one more object to the grid cells parameter.
Okay.
And then the count is there just to make sure I get perfect memory allocation in the next step.
In the next step.
When you initialize the grid map. Or the next function, whatever.
Okay, so let me see if I can get this. So this is called when? At the start?
A init grid map is called at the start, correct.
Top left and bottom right points to the map. This somehow has top left and bottom right points to the map in it. Wait, why is this?
You find it. So I'm iterating throughout.
I see.
Yeah.
Okay.
So that's just like setting up whatever a current point is that's relative to itself, and then I loop throughout the whole thing to find the dimensions of the universe.
Yep, that's fine. Can this change when more stuff spawns?
Can what?
Can this change when more stuff spawns in?
So the way that is set up, nothing should be spawning in, which is why in the beginning you set it up such that only entities that exist from the beginning are going to be in
we will reevaluate for Tokyo Puff mode.
Yes, we can reevaluate for Tokyo Puff.
Is there a map of all of Tokyo? Is that a thing?
Yes, it is. So that's why I brought it up.
That's actually a thing.
Yeah. Japan, the country, released it via the Department of like Transportation or whatever the fuck.
Could you imagine if we did that though?
Dude, it'd be sick. Tokyo Puff.
Can you? Yeah, I know it would be freaking awesome.
It's basically building GTA 6 before GTA 6 exists or whatever.
Well, everything is before GTA 6 exists.
But it's not far off. I mean, realistically, if you just dropped like a million cars inside it.
That's gonna be so freaking cool, man. Okay.
Yeah, dude, just let Project Tokyo Puff evolve, all right?
Yeah,
it's like it's in range. Now, if we do this grid style initialization of my caching,
let's not.
It will
don't
break
tell
all
NYU.
memory.
Don't tell NYU until we actually have something, because they're gonna be like, "What the hell?" That'd be awesome.
Yeah, I mean that's a
yeah. Tokyo.
We can knock that up in part 4.
Yeah. Well, no, I mean, don't tell them, because they're gonna just be like, "What?" Like, they would have to build a whole nother env with the way they have it in Madrona, I'm sure.
Oh yeah, I mean yeah.
Map. The grid cell thing may or may not be totally screwed, by the way. Like, I think you just use like larger grid cells and you're probably fine.
Well, that's good to know, because I mean the grid cell I think is reasonably fast enough.
Yeah, I wouldn't be surprised if you can just use larger grid cells. Like we might also just have to have a list of like active cells or something. So what we might do is if a grid cell has nothing in it, you don't have to process it, right?
Sure, yeah, you can do that.
So we can probably, I think I talked about this architecture with you before anyways. Yeah. I don't think adding the more maps though is going to make it substantially harder to refactor. Because in my mind, the more maps thing should not be very much code at all.
I think it's just a matter of doing the map to binary file
Yep.
one time for all maps ahead of time.
Yep.
And
And you
then I don't
literally
know.
have example, like you have example of this in the puffer grid, right?
I think I did it for tower climb too.
Yeah.
Uh,
I tried to make sure there's example code of everything.
because I did multi-map for tower climb and it was fine. I just wasn't certain about exactly how I'd do it for this one for multi-map because I'm like writing to a file and I don't know if we wanted to write like 10,000 binary files.
Why does it have to write to a file?
I mean, because it's reading from the file. I mean, I guess you could argue you could just send it directly into an array or something,
Yeah,
but
you could. I think we don't need well, you can do it like this for now, let's say.
we'll see. That's one of the reasons why I wanted to kind of talk through
That's
that.
also pretty easy to swap because it's like the save and load logic is going to be the same. It's just going to be fread versus index.
Mm-hmm.
So that's not a big deal. Okay,
So
what the
this was
hell
my
is this
clever
again?
way.
Oh,
Yeah, so
spiral.
this is now this is my clever way of getting the nearest points by so I'm gonna cache in each grid cell the vision of if you're at that cell of all of the nearest entities. Because all of the road objects are static and they never change out the whole point, well, you can do it one time and store your vision for every cell ahead of time.
Store your vision for every cell.
Yeah, so at every location on the grid,
Mm-hmm.
you can store what road objects you see and save them in the order of the closest ones by adding them into it in the order of a spiral pattern around yourself if you index
Oh,
it
I've
that
done
way.
that before. Okay, yeah, I've done that before.
So this is just
But this
creating the
is
spiral
one.
offset.
But this spiral offset's only one grid cell, right? Or do you multiply? Oh, okay, max
What do you
offsets.
mean?
Wait.
Max offsets is the vision range squared.
Is this a correct
So an
spiral?
example,
This
it
is.
is. I have some code at the bottom. Did I or did I take it out? I think I took it out. I had a print file thing at the end
Change
there, but I think I
direction.
took it
Dirt
out.
plus 1% for. Oh, okay. Steps to take. Steps to take plus. Yeah, okay. Spiral code is actually like slightly more annoying than you would think it is to get right.
Oh, it's extremely annoying.
Yeah, I've done this
It
several
also,
times, and it's just like this. It's like this, like you know, CS 101 like
oh
thing,
yeah,
but it's just like it's actually really annoying to get it right.
because like you're like thinking in your head, like, is it
Yes.
that much? Like
Yes.
intuitively, when you read it, it actually doesn't even make sense how
Yeah.
it's a spiral.
Yeah. I've written that function several times. It's extremely annoying. uh,
All right, yeah. Here's all the caching of the spiral at each cell.
so
And
when
so
you
I
say you're
save the
caching the
XY
spiral,
position. Yeah, I'm caching the spiral.
but then the entities all move the next step, don't they?
None of the road segments
Oh,
do.
okay. So your cache, and
So
then
this is
I guess
all an
when you move
optimization to read.
cells, So then
Yep,
when
when
you
you
move
move
cells, you have
cells,
to but you don't have to recompute road positions until you move
exactly.
cells. Okay.
And you don't even actually have to recalculate road position. Oh, yeah, or sorry, yes, you do. Sorry, at
Because it's
when
the
you're computing
order.
observations, you can compute
Yeah.
road. You have to compute the road observation every step, as
Mm-hmm.
always, but you don't have to compute which road segments are near you.
Cool. Yeah, if you sort these, one thing you could try for a perf hack is just like reduce it to 32, the nearest 32 points or whatever.
Oh yeah, I've already changed the vision range. If you go from
Mm-hmm.
21 by 21, which is their range, because each cell is
Mm-hmm.
5 meters is one grid square. So 21 by 21 creates 10 on either side of your center point,
Mm-hmm.
which is equivalent to a 50-meter radius, 5 times 10. If you drop it to 11 by 11, it adds 100,000 steps per second to it.
Yeah. Okay. Cool. At some point, I'm gonna have to actually like help you like really get into this and see what we can optimize. Um, but so far, I think we're in a good spot because I don't think that the map logic is going to dramatically complicate this. This is about as optimized as I wanted it for now.
If I wanted to optimize it even farther, you could argue I could place the parked cars inside of the cache as well. It just makes indexing a little annoying.
You could also just use 4 cores, mate, instead of 2. You could also just use some more cores.
Oh, okay, yeah.
I think your net's the slow piece, anyways.
Yeah, and the actual M logic speed is up to like 1.2 million steps per second.
Then you're fine. I mean, if you get over 1.2 mil, right? Like, yeah, you're gonna have to use 4 cores or whatever, but it's still fine. You're not gonna have it on 1 core. I've realized, anyways. You're not gonna get away from multiprocessing because you need the async factor. So you're gonna have 2 cores at
Yeah.
least, anyways. Also, the bigger networks, as the networks get bigger, it's fine to have smaller batches. What's the result that I had? I have a 3 million param network training right now, which
Oh,
is
that's a
kind of,
big boy.
yeah, it's big for puffer, but it's still fast. You still get 4,500K train speed with that.
Oh wow, really?
Yeah, it doesn't actually hurt you that much.
Huh.
And it's going to get better when we have the 5090s.
Have you gotten yours yet? I haven't gotten any update from Main Gear yet as to where
Delivered on
where my
Sunday. It's going to be delivered this Sunday.
Oh, nice. I know you ordered yours like a few months ahead of mine, so I
Yeah,
don't
so
know when
it's
the
going
hell.
to be a while. And then I have to figure out if I order all of them or not immediately thereafter. Because the facility is going to be done. But so these 2 new ones are the 3 mil.
Those are nice graphs.
Yeah, they're really clean curves, right, with the new stuff.
Mm-hmm.
So this is Muon. This is 100 billion steps, 107 billion.
Are you still doing cosine annealing on this, or are you just
Yeah,
doing flat?
yeah. It is cosine annealed. I don't know if it needs to be.
What made you jump on the annealing train? Because before you were like hard against it.
We've had linear. It was the breakout result requiring linear annealing to do anything.
Mm.
And then it said, okay, well, if we're going to do annealing,
May as well do a
cosine,
better job.
yeah, cosine annealing is like the default across everything in modern AI these days. So, and then
Fair
this is
enough.
a new one. It's actually very tricky to optimize really hard M's like this because look, this is 6 billion steps, and it looks like they're crossing. It looked way better before this, right?
Mm-hmm.
So it's kind of sketch.
Yeah, I can see that.
We have some cool graphs though.
Yeah.
Okay. So, the wrong code. Where's your code? There we go. Okay, so this is your caching code.
Correct. So I read it one time and then I store it the next time in this loop so I can have the optimal memory allocation.
Okay, let me see what this is. Cache neighbor offsets. So this is you getting the cell count,
Correct.
which is when does this get called?
The next cell, I mean the next line.
No, but when does
Are you
this
talking about the whole
is this
cache? One time in init, right after init.
Oh, I see. So for every cell, you go and you do the spiral around it?
Yep.
Okay. Yeah, no, that's reasonable. Get neighbor. So I'm happy with this. You added like an extra 60, 70 lines in initial perf optimization. You know, we'll see whether we come up with a better one after, but this one will be more than enough to get us like on par with the current GPU drive project. And not on par, actually, way faster than the current GPU drive project. I think that's the state of this. Right, I'll have to think
Yeah,
about whether this scales to Tokyo Puff. We'll have to think
sure.
about that, but this will do GPU drive just fine. Okay, you have your init. You pass this. Do your inits. Free initialized. Okay. This is the move logic with the tanh shenanigans.
Yeah, let me link you the thing so
I mean,
you can see what I did.
yeah, I'm not
I
gonna worry
followed
until
the
they come. I'm not gonna worry about the dynamics model until they complain about it.
okay. That is fine.
Intersection code. Where does it spend all the time at the moment? Is it in the collision checks?
Mostly collision check, yeah, because
Mm-hmm.
I
It's
haven't
fast
done a
enough for
recent
now.
profiling, but it's because it's going through every single vehicle entity, every single step.
Yep.
Check neighbors is basically a mini version of the spiral, but only for 3x3 around yourself.
Mm-hmm.
It's only called for collision, but it does it every single car. So
Yeah, so
that's
we're
where,
gonna get a little concerned with like being overly reliant on the spiral pattern at some point. Um, I'm trying to think if that's gonna. Honestly, that might just scale to everything for all I know. The only thing that I think
yeah,
is like possible there is I guess we'll have to see how much data is in like the big ass Tokyo map or whatever eventually.
yeah. All it comes down to is how many entities are going to be in a cell.
Yeah. And that
If
can
it's a really
technically
big
be
number,
dynamic.
you're
It can technically that could be dynamic. It's just like memory indirection.
and then you got some annoying geometry from ninth grade in here.
Yeah, it's really annoying how like the ninth grade geometry is actually hard when you
Yeah,
have to
dude, do you think
like
I remembered this stuff?
yeah
I had to chat GPT my way to victory on this
yeah,
stuff.
and then you got to make sure that it doesn't get it wrong.
Yeah, I mean, luckily that's why visualization helps a lot. Like
Yes, this is
if it,
why we
because
like
I just drew,
games.
all I did was just draw a line from where it was supposed to go, and then if
Yep.
it's in the middle of nowhere, clearly my math is wrong somewhere.
Yeah, collision boxes as a debug tool are really good.
Hello.
Hey Aaron, we're on
What's
stream
up?
by the way.
Yeah, no worries. I just wanted to let you know I've got that sweep running.
Mm-hmm.
I hit a couple of weird pain points on the sweep. We can chat about it tomorrow, as well
Okay.
as when we also look at all these results.
Sounds good. We have I've now run 300 billion steps worth of neural MMO 3 experiments.
Wow. We should figure out a way to speed up my eval because getting the right eval at the end is taking forever.
Oh yeah,
But
that's easy. I can
for
fix
later.
that. That's easy.
Yeah.
It's
Cool.
probably
Yeah,
just
just wanted to let
batching
you
too
know.
many points. It's just bundling too many points together. You just increase the eval interval and it'll be good.
No. I'm doing a custom eval because I want to eval over all of the tasks.
Oh. Okay, yeah. I can figure something out with that.
Yeah, I figure we'll chat about all this stuff tomorrow once we
Mm-hmm.
also have some graphs.
Okay, sounds good. Thanks for the update.
Yep.
See ya.
Later.
Later, Aaron.
It's kind of nice when you just like hang around on Discord and stream all day. It's like, yeah, just updates come in whenever. It's like, how do we schedule a thing? Oh, we just always here.
Yeah, it's pretty good system. Where are you now? Are you on vehicle collisions?
I'm looking at this, whatever this is.
Okay, so there's 4 lines to a rectangle, right? So it's checking to see if each line segment is colliding with another 4 lines of the other car.
I see. Oof. Okay. That was probably fun to write.
Oh yeah, really fun.
Nah, but I expected you had to have to do some stuff like this. Like, I mean, it's a mid-sized project.
I'll say medium large.
Well, it'll be large by the time you have Tokyo Puff in there.
Tokyo Puff is like a grand scale project.
Are you sure it's not going to just end up being like 2K total lines?
Okay, fine. Maybe the lines won't be that much, but in terms of how it sounds and what it does,
Yeah. It's pretty funny when I
I
tell
mean,
people with neural MMO that there's like a fucking dynamic economy in there. They're like,
Yeah,
oh, this looks like a pretty cool end. Yeah, it's like this. It's like, oh, and there's a dynamic economy where you can buy and trade stuff with the other agents. They're like, what?
yeah, and even then, your line of code is, I think, still maybe even less than this.
No, it's not. It's like 2,800 for neural MMO.
Oh, okay, never mind.
No, neural MMO's big. I think neural
All
MMO
right,
currently has the seat for the hardest, like the hardest fast env you can use. I guess except for Go, but Go is like you kind of need search. It's designed for it.
yeah, I think you have to have search to solve that. Well, okay, yeah, maybe you're right. Maybe Tokypuff will only be like double the size of the current env.
I don't think it needs to be that much larger. The only thing I can think of is if the freaking data file's massive, which I'm sure it is.
Yeah, memory will be
But it's
problem.
possible that we just like have to pre-compute a bunch of stuff on that file anyways, right? So it might just be that we have a pre-processing script.
Oh, there's for sure gonna have to be a pre-processing because it's and the pre-processing unfortunately may take like forever.
Well, we'll just do it and we'll upload it somewhere.
Yeah.
You know the puffer color scheme is gonna suit that really well, right? Like this freaking sci-fi Tokyo whatever.
Yeah, it's gonna
Yeah,
be sick.
it's gonna be good. Man. Speaking of which, I should tell Captain I can fix this box.
Yeah, so I took all of the max values from the GPU drive constants, so
Mhm.
those are just copy pasted in terms of normalization.
Yeah, so these checks were a total pain in the ass, one can tell. Oh wait, no, this is ops. Never mind. We're out of collision. Cool.
Yeah, we're in compute observations now.
Yeah, this is fine.
The one of the differences that I took here as opposed to them at the moment is I did not include the other types of road, or what are they called, like map objects
Mhm.
inside of observations and inside my collision checks, because I felt that there was no point in having like your lanes in there until you actually were using lanes as a part of your collision checks. Because right
Yep.
now it's just road edges, and I talked to them about it. They said
Yeah.
that they really only put in the other stuff because they were doing some imitation learning at first, and then eventually they want to do lane stuff. But that, it's just a part of their obs like at this point for no point.
Yep. You're good. No worries there.
Like eventually adding lanes is like a 30-minute change. It's like not a problem.
Yeah, it'll be funny to figure out if we can get like, are you driving legally?
There's probably a pretty simple way, I would imagine, to get it to stay in the lane. It's probably more of a reward tuning thing than anything.
Oh, is Tokyo is gonna be the physics is gonna become 3D though, is the only other thing with that.
That's fine. You just add one more parameter to the
Yeah.
collision grid, just XYZ.
We can just add some ramps in there for fun.
I mean, in theory, this data set does have Z. They just didn't use it.
Yeah, but I think the collision checks, right?
The
Because
collision
the
checks. I
box
think
now can
the
be
math.
angled in 3D.
Yeah, the physics gets annoying. Or I guess not even physics, just geometry. I'd have to grok that. I don't really know how to do whatever vector math that is off the top of my head.
Well, we could just make it not like pitch or whatever. Okay, resets at 91.
Yeah, so my logging is a little weird, I will admit, but because okay, here's what happens. I don't have masking, right? So when you reach the goal, you no longer get another reward after it, and you don't get penalized for collisions afterwards anymore because theoretically you're teleported away to Infinity Land.
Mm-hmm. Yeah, it's rough because we're gonna need masking at some point in this, but it's fine. Fine to do it like this for now. You're still gonna be doing pretty well.
Yeah,
When it
that
gets
was a
sparse,
huge
that
thing.
can stop training. That can stop training from working though. If it gets too sparse.
Yeah, I mean, we'll just have to see how well this does on multi-map. I
Mm-hmm.
mean, maybe it can just figure it out. I don't know.
Yeah.
So I'm gonna unplug my car. All right. We're Gucci. Oh, you're in render now? Okay.
Yeah, I think like I don't know what you wanted me to review because, like, yeah, the collision logic is a little tough. Yeah, there's some caching, but like, I don't see how the map logic is gonna make any of that harder. Okay, this is a Kamehameha right here, but holy Kamehameha
Yeah,
that, man.
it's pretty deep, but it's render code.
I'm gonna have to make a freaking script that goes through the code base and adds like ASCII Kamehameha to any of these in comments.
Yeah, I mean, I don't know. It's looping over each active agent's observations to then draw the lines, the spider web themselves out. You can
It's also
probably
seven. There are also 7 nested if statements, but whatever. I'm not gonna get on your case for that right now. So the map stuff is what you wanted to really talk about, right?
Yeah, so I was not really certain how to go about it because
Okay. So
I was originally thinking like, okay, you probably don't want to write 10,000 plus binary files at once and then store them in a folder because I felt like that was dumb.
you could just fucking do that for now.
I
They're
mean,
tiny,
I
aren't
guess you
they?
could. Are you fine with that? I mean, it's a little
Well,
jank.
do it for
And then you just
now. It'll take you a few minutes to do that, and because you're literally just calling your load code with a random index and you're done.
and then should I follow the same way that they did for swapping between levels? Because there's going to be some overhead every time you create the cache. So they did it every 2 million steps. I think they resampled everyone. Well, how would you want resampling to go on the levels? Because you wouldn't want it to be every single 91 steps, because then the caching would nuke your performance.
Yeah, so that's going to be the thing that is probably going to require some architecture changes at some point. I mean, the way I did it, these maps aren't huge, right? How much memory these things take up?
I've never actually checked,
Okay, how
really.
big is the file?
I can check that real quick.
Mm-hmm.
283 kilobytes.
And then with the caching stuff, is the cache pretty big? How big is that object?
I guess I could go based off of max size. So let me just take a look at the code real quick. How big is the cache? Okay, so your grid cells, so just the grid cell count, and then the slots per cell. How much is this? Max entities per cell times 2 plus 1, so that's 21. Times the grid cell. So I think the grid is like 40 by, like it's like 50 by 50. So 2,500 times 20, so to the 50,000 ints of just grid cells.
50,000 ints. So that's just
And
200
then
KB.
And then at each cell, you have a vision range spiral of n squared of whatever your vision is times max entities times 2.
So you actually do have like a shit ton of
Pretty
memory.
big.
Yeah. That's going to be
it
like
becomes.
many megabytes at least.
I think it will be in the megabyte range. I don't think it gets to the gigabyte range, but it may get close if your map is really big.
Yeah, well, and that's going to be an issue because like there are a lot of maps, right? It's like 100K
Yeah.
maps or something.
I thought it was smaller than that, but maybe it
I forget
is.
how many they had. They had a lot of them. So yeah,
I think it's at least 10K.
So what I was gonna try to see is like, oh, can we just compute it for everything, and then just like hash the entire M state? But
Oh.
yeah, that's probably gonna be too much. How
Trying
many
to find
M's are
out
you
how
using
many.
right now? You're using like 128 M's or whatever.
Yeah, I'm using 128 right now.
Okay, so as a first order of business, can you just like train on 128 M's? Just randomly pick a map
Like,
on in it,
Just
and then
randomly
don't.
pick 100. Just randomly pick 128 maps,
Yeah.
And then what? Just so every time I go to it, write the file and then upload it
Well,
again.
literally, all you have to do is like pick
just
128
rewrite.
maps.
Just
No,
write over the files.
no, man, just pick 128 maps, run your pre-processing script, and then your C just loads it, and you're done.
Oh, you're saying just try it out for 128 maps
Yeah.
in one go.
Yeah, I mean, just run your pre-processing script to dump the 128 maps, and then you
Yeah.
can load them in. Right, just pick, index 1, 2, 3, 4, whatever.
Yeah. Just attach that to the name of the file. Yeah.
And you're done. And then you'll be able to train on
Oh.
128, and we'll be able to get an idea of what happens when we do that.
Yeah, I could do that.
Mm-hmm. And then, if we figure out what's screw with the batch sizes, we can do like 256 or whatever. And then if you have 2 workers, we potentially can add an offset or something so that it's 500 maps, and now we're already kind of getting to something reasonable.
Okay, so here's where I have another
Mm-hmm.
one sec. Okay, so if you go to my Python file, here's where multi-map I have an issue with. Observation size is dependent on how many of the active number cars there are. Which
Fair.
for this map is 67. Num obs, line 24. So it's
What's
based
this?
off of yourself. It's based off of yourself plus the other amount of cars times the features times 200 is the max.
You can see all the other cars.
You can potentially see all the other cars.
What the hell's the point of the spiral if you can see all the other cars? Do not get them in the spiral?
You don't no. If it's in the spiral, you get them. Otherwise, they're just a bunch of negative ones. So, what is the maximum allowed number of agents do we want to set is the question.
Just pick a number and take the nearest n, right?
I mean, I can just blank face pick a number, I guess. I mean, it's not like
pick
it really...
32 or something. They're not going to have more than 32 cars around you anyways. Right?
I mean, I think.
Do you have more than 32 cars in a... I guess it's the radius is more than 3 by 3.
Because the radius is 50 meters by 50 meters.
Isn't it? Don't you have the spiral thing for nearest anyways, right?
Yeah, it is.
Okay, so just stop when you hit 32. Done.
Yeah, I mean, I can totally do that. It just matters if we're gonna lose any performance. That's all. I guess we can just try.
We'll see. And then
we'll
you know
find
what the
out,
really
right?
cool thing is with the renderer is that you're going to actually be able to draw which cars that it can see and which ones it can't if we need to debug it.
Yeah, I can actually.
Yeah.
I mean, I think
'Cause
you
I
already
saw you
saw it,
had
but
that, like, you had the really cool ops thing. Well, we can just, we can just add some indicator if it can't see the cars because it's hit max. Like, but you
yeah,
don't
I
even
can.
need to bother with
I
that
just
for
shared.
now.
Yeah, I just shared my screen, so you can see what
How it does it. So if I just have it pick a smaller number, that's totally fine. If it hits the number, it's filled, and once
Yeah,
it's
none of
filled,
that
then
shit over there
let's.
matters, right? Like, it has
Yeah, like
massive.
arguably the cars. Yeah, like these cars on the right arguably don't matter, and like these cars don't
Yeah.
matter.
So
But like maybe.
we're gonna be able to optimize a ton of this stuff. Like, it doesn't matter. Just for now, pick a number, you'll be good. It'll learn.
All right, that's fine.
Yeah.
That's
And then
fine.
your obs is now a fixed size, right?
Yep.
And 200 road points is probably too big. That's probably killing your net perf. Right?
There's quite a bit of road points, but I mean, you probably don't need this road point like up the top.
They're sorted roughly by nearest anyways, right?
Correct. It's always sorted by nearest because
Yeah.
they're cached in a spiral.
You can literally drive just fine with the nearest 10 of them.
I'll pick a number. I think 10's too small.
Yeah, I
but
think it's too
yeah.
small as well for like max perf, but 200 is nutty. Like, you'd be fine with 64 or whatever, and you'll be training at 1.5
Yeah.
SPS, and you'll be done.
For sure would definitely probably get to 1,000,000 SPS if I picked like 60 or something, like you said, like 64 and 32
yeah,
on the
64,
cars.
32, call it a day. Let's see this
Yeah.
thing running on. Let's see this thing running on a bunch of M's. These
Yeah.
maps don't have buildings in them, do they?
No buildings.
Damn, that'd be so nice.
Yeah, it would be great for rendering if you could have like a little bit of like a
We might
town
want to
next to
add
you.
some. We could add some.
For the purposes of social media, sure, I could randomly place buildings.
They're like, man, there are so many like city gen algorithms, like, that you could just grab. You just put it everywhere that's not road.
Not road and not parked car
Yeah.
for whatever reason that these parked cars
I don't even
exist.
know why those are there.
It's just some, I don't know, dude. I think it's just a matter of the data set.
Mm-hmm.
They just like exist. Technically, some of these cars originally are supposed to be agents, but we filter them out because their goal is like 1 inch from themselves.
Mm-hmm.
So they set the filter to be, you only determine a car to be an active agent if they're greater than 2 meters away in distance to goal from spawn.
Yeah, I think we're gonna have to do way longer than 9 second. I mean, that's ridiculous, right?
It is, but if you also think about it, I don't know how many major driving interactions last maybe longer than 15 seconds.
Yeah, but it's lame, right?
Like in terms of like unique things you're doing while you drive.
Yeah, it's lame though.
I mean, even like a 4-second stop sign doesn't even take that long. Like a 4-way stop sign if every single car is there.
But I want to watch the agents just drive around constantly.
Yeah, I see that. I mean, I also like watching the Rware robots permanently solve putting boxes inside of its goal.
You know, if we wanted to actually do something in that industry, I would literally just we just make that thing be able to have continuous movement and then jazz up the render to be like 3D actual warehouse, and boom, there you go.
Yeah.
Right?
Yeah. I mean,
That's literally all you would do. And then you'd be like, boom, okay, now we have realistic warehouse aura. Just from like freaking making the renderer half decent.
Yeah, instead of not like some jank ass little
Yeah.
2D colored box. Yeah, for sure.
That's actually probably going to be a thing that happens, by the way, at some point in the future with Puffer. Is like we just actually start caring way more about making the M's look like what they actually are.
Hey man, I see that. I mean, I set the tone going
Yeah.
forward with Tower Climb. I mean, that's like
Yeah, those are
graphics
cool.
the
Those
shit
are
out of
cool.
itself.
Yeah, it's cool.
But yeah, I would like to have permanent cars and also having goals, pick new goals after you hit a goal. Which is why it'd be great to have a larger map so you can have indefinitely running car simulation and you can even track like traffic patterns at that point.
Yeah, would be cool. Just etiquette for using
So-
Git co-author. I don't know what you're asking, Jason. Yeah, like, why is there are no cars on like the vast majority of that map?
I don't know, man. It's just like the data. Like I don't even know why like this even exists over here.
I like literally if you were to just do max distance, like, just you get rewarded for going max speed and not hitting anything, and you were to just spawn cars randomly, you could already do stuff with that. Right?
Yeah, I mean, I think even if we get like the new plan data set, like I think that they've been talking with those guys about, I think their maps are decently large.
Okay, cool. Well, we will do something. Just get the thing training on 128 or whatever maps for now, so that like, there's like a reasonable policy, and then yeah, we'll go from there.
Okay, so you get a 128 policy going. Do the simple
Mhm.
dumb approach of just uploading all the maps at once,
Yes.
and then
You should notice that training is a lot easier than it was a week ago with the new algorithms and stuff.
I have it in there unless you put something in like yesterday.
No, Muon is there by default now. What, are your policies still not training?
No, my policies do train. I
Okay.
shared that result over on Discord.
Well, I think that you'll have not too much trouble working on more maps then, because the new algorithm is a lot less fiddly than just Atom.
I actually think more maps will be easier.
Mhm.
Surprisingly, like
Yeah,
I think just the
it
data
should be.
diversity will just be helpful as opposed to like it randomly trying to figure out the
Mhm.
like, oh, there's a goal like over here and all the other
Mhm.
agents' goals are over here.
It should be.
Like
Alright.
it definitely should be easier. But unless I have an env bug, which is possible, but I mean, I
Mhm.
think it looks pretty clean thus far.
That's good. I'd help you at some point with this render as well. Yeah,
This is just to like find out if things work, all right?
yeah.
We haven't jazzed it up yet.
Yeah.
But
I mean, we're gonna have to go license the car models from the car companies.
oh yeah, we'll go talk to Tesla, okay, and
Yeah.
get like a little car model. What if we even then just get like car partnerships via like ads for other car companies to just have their things running here? Ooh, boom.
Yeah, that's even better. Now we don't pay them for licensing; you pay us for marketing.
Yeah, exactly.
Isn't it funny how you can just flip the thing and just have the same exact?
Yep.
You pay us, we pay you. You pay us, we pay you.
And then I do want to add first person mode in here and drop the camera in the
Mhm.
perspective of the car.
Oh yeah.
That'll be fun to play with, and it'll be cool to demo
You can
online.
also do like the third person racing perspective.
Yeah, where you just like right on the tail of the car, but a little bit above it.
That's probably even cooler if you get a decent car model, because then you actually see the car.
Sure.
Yeah, that's how all the racing games are right now. Are any of them even first person? Is that a thing?
I think you can always swap into first person mode, but I think
Yeah.
most games are played as a user from that like
Yeah.
just behind third person mode.
Yeah. I'll go look at Trackmania or something.
Yeah.
All right, cool.
But okay, doke, yeah,
Any other
that works.
questions, Spencer?
Once we get the policy going on 128 and it seems decent, is that something that we want to present to the NYU group, or at what point do we want to be like, hey, this is like in a good place for you guys to use, or at what point do you feel like it's like
they're gonna want to be able to train on all their maps, but no, this is
okay?
We're only 2 hops away now.
Yeah, sure.
Yeah.
128 and then 10,000. Why not?
Well, I think that we probably will have to just revisit the state size, and the best way to do it is that your state load is like a mem copy or like a small number of mem copies, right? You can look at how I did this with the grid env, because I have a full example in a simpler env there for you.
I was having a hard time trying to figure out how I would use any mem copies here, but
What you do is you make a struct that's the state, right? The game state. Okay. And then and that just has data, and then you make like a load state or save state, that just copies the data from one struct to another, right? So then you just end up with a struct that has the state of every env at initialization. And then in order to load a map, you just copy it, yeah. So you
Okay.
basically,
Okay.
yeah, that's how the
Yeah,
grid works.
I can kind of follow that.
Yeah.
But I guess who's in each? Okay, here's where I get a little lost. If each one has their own end, is that all happening in the Scython then, so that it's shared amongst
So
everybody?
the struct definitions and like the load state, save state, all those methods, that goes in C.
Yeah.
And then the actual array of levels goes in Python. This is in the grid example code. So if I
Okay.
just pull up the grid example code right here. Where's it? Goshen.
Is that what I did for tower time? I don't even remember.
Literally, you have an example right here. So levels is an array of states.
Yeah.
And then here you can see get state. So I get the state for all the different M's, and I save it to levels. And then there's a set state. And that's all the logic that's in here. And then all the other stuff, get state, set state. Like all the state stuff is in C.
All right. I did the same thing with tower climb too. I was just confirming that.
Until
Yeah,
I decided
I have
to delete
a level.
Python.
Yeah. But the grid will probably be even easier to even read what I own did for myself.
Mm-hmm. That's it.
That's right. Yeah, that's a thing. I could just make a struct that's the state at initialization post.
That's what I would suggest.
Yeah.
But don't bother with that yet. Just get the 128 training.
Yeah, get the 128 going. Yeah. I mean,
Box
I'll probably
good,
be able to
right?
get the 128 going by this weekend, realistically.
Yeah. You don't have your box is working, right?
Yeah, my box is good. Unless it just nuked itself like now.
Thankfully, everybody's freaking messaging me with hardware issues all the time. All right, we're good. Cool.
Okay.
All right.
I will see you later and let you know how 128 goes.
See you, Spencer. Thanks for good progress on the end. Okay. That was cool. Spencer's made really good progress. I'm gonna take a minute. Walk around a second, use the restroom, all that, and then I will be back. We're gonna do a couple just example training runs on stuff, and then that'll be it. It'll be dinner, and then tomorrow will be probably all day infrastructure work on Puffer, and that'll all be live. Be right back. Okay. Here's the plan. About 40 minutes to fiddle with some experiments, and then dinner. I'm getting hungry. Ah, wait, I need to do, I need to grab their latest branch, I think. Sync can work off of that, okay. We'll let that run. My guess is I just, like, deleted some of their losses or something. So basically, I'm just, I did a merge into this repo with all our new dev features, and train's a little worse than before. So I probably broke a couple things. I mean, it was like a big merge, so it was kind of expected. Frankly, I was surprised the training worked like reasonably well at all on their first go. So see if I can spot, any discrepancies real quick. Get a couple runs going, and we'll go from there. Okay. Apparently this is supposed to do stuff. We don't have episode reward in here yet. Okay, so that actually trains quite slow. Ah, no, it gets faster though. Okay, let's move on. So while I'm waiting for this, let me go look at their original code here. Why did they merge this into main? Oh no, they didn't. That's my branch. Never mind. Okay. Merge. So what do they do with their losses? Oh yeah, they got a whole bunch of these. So they got Kickstarter, KS Value. They got this L2 as well. This is now with their regularization added back in. Let me see what else could be different in the meantime. So they don't use this kickstart thing. That's like the main thing I was expecting. Oh, okay. It's probably just this, isn't it? Yeah. Okay, that's definitely it. How does this thing not freaking work? There we go. I think I should sweep L2 regularization. How many steps is this? Okay, we'll let this run a little longer. This should do very nicely, though. Sit. Almost 6. We'll give this a few minutes then. And may as well check on my other runs in the meanwhile. Now that is something I can do because this guy's not doing so hot, right? Yeah, this guy's not doing so hot. We should go double check how much L2 they're using. It makes that much of a difference for them. Well, they have no L2. So I don't know how that made any difference for them. Yeah, these are zeros. So they're not actually doing L2. So what do I run on neural MMO then? I basically just get to run an ablation of some sort, right? Yeah, it's stuck at 1. Still lower, but not much lower. This one has 0.9. 0.9, 0.999. 20 minus 12. Okay, we'll double check the betas then. No, these have the same params. These muon params are the same. Does seem kind of stuck. Oh, you screwed this up totally, didn't you? Maybe not. Yeah, whatever. 32K. I'm trying to think what else I could have broken. This is the wrong one. I got his experiment by mistake. We'll see if the mini batch makes a difference. Makes it a little faster. I think what else I could have broken. It's kind of rare to like break something and have it like still mostly train. Usually you either full break it or you don't. It's annoying. It changed. Optimizer changed, I guess. I mean, to be fair, I don't know how they had it working before. Like, I tried to reproduce their result and I couldn't. I don't think if there's anything else that they might have done. Config average reward. Do they do this? I don't see it in here anywhere. They don't use either of these losses. They have this weight clipping. Nope, they're not using that either. Do they have annealing on? They have anneal to false. But that shouldn't matter. This is just rank logging. I did this correctly, right? In theirs. Let's go check the LSTM state. Yeah, that wouldn't work at all without this, right? I did add reward clipping. Did they have reward clipping? They do not have reward clipping. We'll try that next. But I want to see if this gets any better. Okay, we'll see where this gets to. Ugh, man. Is this scammer? Yep. Hey, this is cool. 2 million, not enough though. It's a tiny, tiny amount of data. I'm trying to think if it makes sense that this would be a reward thing, right? I remember this being a thing in Breakout the other way. it could be that the rewards are just horribly scaled. And, you know, that could be a thing. We'll have to see. Plus, hang on, he sent me another ARG. I already had it though. We're gonna level out again. Just take longer to get there. We'll try this thing next. Whoops. Wrong language. We'll let this finish 250. And then I'll just run the other thing and I'll go get dinner. Non-tensor data within tensor dict. What the heck? That was weird. Huh? XAI has acquired X. That's a weird one. Surprised you can even do that. That's interesting. That's annoying. Okay, this is what we'll do. Set this to clip rewards. Maybe that's a clue. Why train is slower. Oh, it could be the stupid gradient variance thing. Reward flipping doesn't seem to make a big difference. It's weird. Very weird. So we're not going to get anything out of reward flipping, it looks like. And that should be there anyways. I can double check the LSTM state. It'd be really weird if it were doing this well without LSTM state though. Oh. Okay. Oh, is this going to be stuck again? Damn it. Yeah, that's crazy that it does that. It does a little better without reward flipping though. Well, I still should check the LSTM states. What's the default supposed to do? It's minutes. So like 100 mil steps, it's supposed to be pretty low. 200 gets to like 1.25-ish. 250 mil. We're not that far off, and we only have to get up to here. Wouldn't it be funny if it were just clipping? It'd be surprising. Wow. I guess stranger things have happened. I do know that that specific parameter is quite sensitive. What else would cause it to stall? Learning rate params, for sure. I'm trying to think if there's any specific bug that does this, but I think it's more likely just hypers and stuff. I mean, I guess I could have technically broken. If I broke indexing, though, it would be like giga broken, wouldn't it? It wouldn't do anywhere near this well. It wouldn't be certainly like close to where their original is. It's a little under. Honestly, it doesn't look too far off from theirs. That definitely did something at the very least. The thing is, the curve shape is off. Let me see if I missed any of their other normalization stuff. Did I do the schedule step? I think I did, right? Okay, I think I'm just going to keep running a couple of these in the background and figure it out slowly. Yeah, I gotta just play with their thing. Okay. Neptune run. Early gamma has potential here. Okay, I'm gonna go get dinner. I may or may not be back after. I will be live all day tomorrow, most likely streaming infrastructure dev on Puffer. So if you're interested in that, swing by tomorrow. And otherwise, puffer.ai, all my stuff's here. Start the GitHub to help us out. Really, really helps us out a lot. You can join the Discord to get involved. You can follow me on X for more content.